In the earlier video, we have discussed about peer-to-peer mailing list implementation, but some of the discussions actually were missed out. So this video is, I am discussing about something more on this peer-to-peer mailing lists. So what we discussed in the earlier one, there was a list server DHT. So all the nodes who connect as list servers will register in that DHT. So any node who actually want to find out that want to generate a list, he will create a list name. He will also append his owner's ID the way it has been shown here. So this will be a colon which will be used, and then of course a copy one. Reason being, I am implicitly assume that there will be two copies maintained for every data structure for the list. So this is for resilience purpose, the way we had done in the discussed in the earlier videos. Same way it is done here. Okay. So I am not mentioning that the moment when I say copy 1, computing hash, it goes here, it will generate a copy 2 actually, which will go to another root node, which in turn will maintain the copy 1. So if a node goes off, automatically the copy 1 structure will move to somewhere else. Okay, a new node comes in, that should become the root node, then all the data structure will move. So all that is going to hold. So with this we actually do the compute the hash of this particular structure. We will append copy 1 here. We will get a hash ID. We will find out the root node for this. Let this root node be this particular node. Now all these black circles which I have shown inside this list server DHT, these are the nodes which can act as list servers. It's basically node ID space which I have shown. And these nodes we have formed a list server DHT. Now what this root node is going to store? So when the owner is going to publish that, okay, you are the guy, so I am creating a list. So it will create a list data structure which will look something like this. It will contain list name, owner's user ID, and when you do underscore copy 1, compute the hash and root, you will come to the root node, and you will this particular structure will be published there. It will contain all the members' user ID, whatever number which are there, whether they have permission to post or not, whether it will require moderation or it's a moderated free. Okay. And of course, this whole list need to be signed by the person who has created the list. So this owner's user ID should have signed this particular list. Otherwise, the root should not maintain this data structure. So this was not stated earlier explicitly, but I am stating it now. Now, a sender wants to send a message to this list. How this can be done? So I had discussed this thing in the previous video. So it will create a message, and as I had mentioned earlier, that there is going to be group key. For whole group there is a key which the group owner will be sending or dispatching it to all members. When the membership is going to be updated, that time it's going to generate a key and send it. Of course, when you remove somebody from the list, you remove it from the root, but if somehow that guy actually still gets a message, he will be able to decrypt it unless you change the group key and then communicate it to everybody. So anybody who want to post will actually take the message. It will encrypt with the group key. It will attach its own signature so that people can identify who is the person who has sent this particular message to the group. And then it will again compute list name, colon, owner's user ID, and will append a copy 1, compute the hash, and to this root node it is going to send this whole message. So that root node who is in the list server DHT can now send it to all members of the list. So let's call this node as R. So what R will do is, if it's going to have a huge list, for example, it's a K into 100 kind of list, so it can create K groups, each one of 100, and of course once it has done that, the message is there. So this is what was discussed in the earlier one. So I am going to today talk about an alternative method also. So R will send the list 1, the complete list plus signed encrypted message to member 1. So member 1 will further send the message copy to each of the list members. So from member 2 to member 100. Alternatively, member 1 can actually further split the list. So like this, member 2 to 50 is first list, member 51 to 100 in the next one. And then it can send this particular list 1.1 and the message to member 2. And member 2 will further then look at this whole list and will send it to 3 to 50. And member 51 will be getting a message again from this member 1 along with this whole list, and he will further split it from 50 to 200 members. So this will look something like this. R has sent it to 101 and 201 along with the list to whom, or basically list of all the children to whom the message have to go. One has further forked it out and gave again a sub list of the children to whom the message should go, and given it to 2 of the nodes which can do the further fork. So in this case 2 is giving it to all 3 to 50 node, 51 is giving to 50 to 200, and so on, this 2 for even for these. So message reaches to everyone. So this is what I had talked about in the previous lecture. Now the problem here is that the members can become aware of who all are the list members. May not be the whole list, but even partial list will be available to them. Sometimes it is not desirable. In fact, in actual most of the list server implementations, it is only available to certain people. Not everybody can see who all are the members unless you permit it in the list. So we need to have an implementation need to be changed. So what we can do is, why R was not sending it to all K200 nodes? Because the message was large and sending it would have taken time, processing and sending. So alternative way is that R can actually keep the message with itself. So R has kept a message, for example, here, and we will compute the hash of that message, and this R now send it to each member a message which is going to contain the list ID and hash of the message content. Okay, so message is not going to be sent. So everybody will come to know that there is a new message which has arrived in this list ID, and this is the hash value. Now here we can actually play a trick around. So the member 1, for example, sends a query that I want to get this message now. So it knows already a list ID, which is going to be list name colon owner's user ID. It will append copy 1, compute hash, find, and it will send to this particular destination a request that I want to retrieve this message with this hash. So the HM which has been given. So message will reach all the way to the root node, and root node will either through a DHT route or directly through the endpoint address will send a message. So member 1 as a list member has got the message now, and he can read the message. Now we need to do something more, because if there is going to be say 10,000 members, all of their queries will be coming to R, and R is need to serve it actually. If suddenly all of them become active and all of them want to access it, it's going to be a bottleneck. So we need to use another phenomena called caching here. So R, when it sends to 1, it will also know that from which route the query arrived. So it will also send a copy of this particular message. Remember, it's encrypted, so it's safe actually, and the hash value both to the previous node from which the query arrived, and it will be cached here. So the cache is shown here. So there is an index, the hash, content hash, which is used as an index entry or key entry, and there is a encrypted message. This is now available with it. Now suppose member 2 wants to also get the access to it. It will send a query travels, it reaches here. There is already things which are there in the cache. So every node, whenever a query arrives, before forwarding it towards root, will search if it is already there in the cache. If it is not there, then only it should send it towards the root node. Otherwise, you serve the message from your cache itself. So it will now search for this content hash. It will take this message out and it will send it directly or through DHT route to member 2. And it will also then send a cache entry for caching towards the node from which the query arrived. So what happened is, more and more people are trying to access it. So more and more neighbors around R will start having the cached entry for this particular message. Now this essentially means that R, all the neighbors will start having the entries, and more people will access it, will start spreading out more and more. And this caching will allow that large number of nodes in a very short span of time, without loading root node, can have an access to the message. And we normally, for these cached messages, you can keep expiry timer of say 30 minutes. So when the load reduces, not many people are accessing, this will automatically get purged from the entry. So whenever the sudden burst of queries which will happen, those can be handled very effectively with this method. Of course, there is one more feature which exists, which is moderation. Okay, I had also not discussed anything about moderation in the earlier case. So moderation, the moment that comes into picture and moderation is configured in them, so all posted messages which are not permitted to go through without moderation, they will be just held up in the root node R, and R is now supposed to also maintain a list of moderators. This is another data structure in listserv which need to be now populated by the owner. Owner will say these people are the moderators. Okay, so he creates the list, he creates the moderators, and whenever a message comes which need to be moderated, cleared, a message need to be sent by list server or that root node to all the moderators which are listed. So all the moderators will get it. Okay, and once the moderator will get this particular list, and so they need to now clear it. But if they give a clearance message or they give a message to reject it or drop it, the method has to be distally signed so that list server can identify which particular moderator has responded, and then it will act accordingly. So tomorrow, for example, if somebody has done a wrong moderation, the owner can find out who did this wrong thing and he can be removed from the moderator list actually. So when the clearance is received, the message will be sent to all the members. Now we need to understand that a message has been sent from sender to R in this case, which is a root node or the list server. R has sent the message to moderators, moderators to again send a message back to R has sent it to members, or R has sent to members which have further sent it to members. Now all these messages are not direct transactions. They all actually use peer-to-peer mailing system for sending of the messages, because that's important. So normally when you are sending it to a list server, it may be off, but in that case somebody else will be acting as a list server for you. So list server is always alive. So there it can be directly peer-to-peer transaction. You don't require mail storage system. But when you are sending to moderators or when you are sending it to members, then you will be using peer-to-peer mail system for transacting or for transferring the messages. So this was something additional which I missed out in the previous lecture, so which I wanted to clarify. So I had done this in this particular one. So in the next video, we will be looking into a new concept of peer-to-peer web and how the peer-to-peer search engines actually can be built using this whole formalism.